All right, Math 2015 students, I'm going to give a little bit of a preview activity for our next learning outcome, which will start on Friday. Start next class is learning outcome, preview of learning outcome 2. So in algebra, we have traditionally done equations in a certain way, but that's because you were in high school or junior high, late junior high, and you started learning math in a very abstract way, different way of thinking. But elementary students need to also learn some of these techniques, and they have the intuitive ideas, but they need to be kind of channeled and focused in a certain way. And that's what we're going to do in learning outcome number 2. But for the transition here, I want to just kind of go over traditional and regular algebra equations. Okay, so here we're going to go ahead and do a few examples here. We're going to start out with one-step equations. I'm actually going to title this as a transition video from learning outcome 1 to learning outcome 2. Okay, so we're kind of transitioning to learning outcome 2. Okay, so one-step equations. Okay, we have one-step equations that we can work with here, and just to help remember how algebra works traditionally. And then we're going to, in learning outcome 2, we're going to investigate more about how elementary students can go into that. So we have in the first example for learning one-step equations, x minus 3 is equal to 11. Okay, and so an elementary student will think about this and they'll say, well, what number subtract 3 equals 11? And they can just start guessing and checking. And we'll talk more about this on Friday. But we can know that 14 minus 3 is 11. But in the algebra sense, we don't worry about looking at it as a whole, okay, thinking about this side of the equation and this side of the equation. We just do a mechanical operation where we just add 3 to both sides. And so most people put the 3's on the bottom. Those will cancel. X is equal to 14. Okay? So just to have us review what the traditional sense is, and we're going to do a few more. Okay, so we'll do another example over here. Okay, traditional sense, x plus 5, x plus 6 equals 15. Okay, so as you remember, we want to solve for x and get rid of anything on the x side, so we're going to do the opposite operation by subtracting 6 from both sides. That will cancel. X is equal to 15 minus 6, which is 9. Okay, so example number 3. I want you guys to do this one on your own. Solve it for x, use traditional methods, and pause the video, and then you can resume the video when you're done. Okay. All right, so now we've resumed it. We have 3 times x here, so we're going to divide by 3, so the 3's will cancel there. 15 divided by 3 is equal to 5. Okay. Again, example number 4. Let's go and pause the video, solve the equation, one-step equation, and compare with how I do it here. All right, we have our one-step equation of x over 4 is equal to 10. X divided by 4 is 10. So what number divided by 4 is 10? Well, pause the video and you can figure that out. Okay, so we'll resume again. 4 times x over 4 and 10 times 4, those will cancel out so that x is equal to 40. Okay. Those are one-step equations. And two-step equations is the next level, and that's as far as we'll go. Just to help remember algebra. and how we traditionally do algebra. Okay, so example number 5, we're going to say, okay, we're going to do 5n plus 5 is equal to 45. Okay, two-step equations. We're going to do 2 moves with math operations, and usually it's going to be multiplication and division or addition and subtraction. Those are the 2 steps. Pause the video, solve the equation for the n, and then compare. Okay, now that you've solved that, let's go ahead and go through that again. We want to peel back the equation like an onion, where we'll take care of the plus 5 first. Okay, plus 5, and then we'll take care of the 5n. Okay, so taking care of the plus 5, we'll go ahead and subtract 5 from both sides, using opposite operations to cancel. 5n is equal to 40. Divide by 5, because 5 times n is 40. Do the opposite of timesing by 5, dividing by 5. And n is going to equal 8. Okay, here's our next example. 11 is equal to 9 plus b over 8. Okay, and so notice that the equation is kind of reversed, but it doesn't matter because this means the equation symbol means equal sign means the same as, so it doesn't matter which way you go. But we're going to kind of peel back the equation to get to b. So pause the video and solve for b, and then compare once you're done. Okay, so let's go ahead and get to the b. We have an addition here, and then we have division. So we'll go ahead and subtract off 9 from both sides to maintain equality, right? Then we have 11 minus 9 is 2 equals b over 8. And then to maintain equality here, we'll multiply by 8. Oh, sorry, 8 here. And then those will cancel, multiply by 8 over here, and b is going to equal to 16. Example number 7, we're going to do y over 6, subtract off 3 is equal to 9. Okay, so algebra, go ahead and pause the video, solve this equation. Okay, so we're going to go ahead and solve this equation by adding 3 to both sides, doing the opposite operation. Those will cancel. Y over 6 is equal to 9. And again, we will multiply by 6 here and multiply by 6 here. Those will cancel. Y is equal to 9 times 6 is 54. Oops, I think I made a mistake there. Back up. Y over 6 is going to equal 12 because I did not add the 9 3. Okay, so it can happen to anybody. And what we're going to do is we're going to now multiply by 6. Something was about fishy about that one. Okay, so y is equal to 72. That's better. Example 8. We have 2p minus 3 is equal to 19. Okay, pause the video and see how to do this one. Okay, so here we're resuming again. So we're going to add 3 to both sides. Peeling back like an onion to get to the p. So take care of these ones first. 2p is equal to 22. And then since 2 is multiplying by p, I can divide by 2. According to the traditional algebra rules, p is going to equal to 11. Okay, so there's a little bit of a transition. We'll study about what elementary students would probably do with these equations in learning outcome number 2. I hope you guys all have a great day.